Hi, I'm Claire Marsh. I'm a grade 8 French immersion student at Rolling Meadows, and I'm excited to share with you my innovation, the EduComm device. The purpose of the EduComm device is to make a device that is solar powered and doesn't need Wi-Fi, cellular data, or internet to help educate children who are unable to go to school in person for various reasons in developing countries. Millions of families in developing countries don't have access to reliable internet, which results in children being deprived of a stable education when situations occur that prevent them from being able to get to school. Situations like injuries, menstruation, the distance to school, children with disabilities, having to care for family members, and COVID-19 outbreaks. My question is, what can be changed about remote learning and how it is done so that more children in developing countries will have access to an education? My hypothesis is, if the platform, internet, cellular data, Wi-Fi, etc., used for remote learning is changed in some cases, more children in developing countries will be able to receive an education. I think another benefit would be that you wouldn't need electricity to charge it. Instead, it would be solar powered. This form of charging would be eco-friendly and help reduce barriers around remote education. People are already thinking about using walkie-talkies for educational purposes in isolated communities. However, many children are visual learners and they cannot grasp concepts only through auditory learning. Therefore, creating a different tool for learning that has a screen for visual learners and doesn't rely on internet will offer a more accessible and convenient option for educating children in developing countries. The EduComm device has two different types of devices. The first is a student's device and the second is a teacher's device. The main difference between these two types is that the teacher's device has a camera that sends monochrome, which is black and white, pictures to all the student devices. The student's device has a screen so that the student can use the photos as a visual component to the lessons they are currently learning. And the teacher's device has one so they can look at the photo before they send it and review previous lessons. Both types of devices would be able to communicate with each other orally as well. This is the teacher's device. It has a charger spot, talk button, speaker, camera, antenna, screen, on/off button, and a channel dial. It is 6 inches high, 8 inches long, and 1.5 inches wide. It has a 6-inch antenna as well. This is the student's device. It has a charger spot, talk button, speaker, antenna, screen, on/off button, and a channel dial. It is 7 inches high, 9 inches long, and 1.5 inches wide. It has a 6-inch antenna as well. These are my prototypes which I 3D printed. They aren't to scale, they're a bit smaller, but this is what they would look like. The image transmission would work like this. First, the picture is taken. Next, it's processed in the teacher's device. Then, the image would pop up on the screen and they'd have the option to either select it or take another picture. Once they select an image, it is encoded by scanning the pixels in the image for brightness and darkness values. Since the images would be monochrome, there would only need to be 2 different audio frequency values. The teacher's device would then send the image out in radio waves. Each pixel would be 8 wavelengths, which is 1 byte, or 8 bits, which would equal out to 1 wavelength per bit. As long as all the students' devices are on the same channel as the teacher, they would receive the radio waves, then they would be processed and encoded and translated back into an image. The image would then appear on the screen. My innovation would be a useful tool because millions of families in developing countries don't have easy access or the ability to attend school in person. Without reliable internet or a school within walking distance, children are unable to receive a basic and stable education. In addition, it would be helpful in war-torn countries where people are afraid to leave their houses for fear of being arrested. The amount of children that are out of school in developing countries has only gotten worse during the pandemic. It is estimated that globally more than 870 million students at all levels have faced disruptions to their education. For families that don't have reliable internet in low-income countries means that in many cases, children are not able to continue with their schoolwork guided by a teacher. Another reason why it would be useful is because it doesn't require electricity, and instead uses a natural source of power. solar power. Many homes in developing countries don't have reliable electricity for various reasons such as cost, infrastructure, and unstable government. Using solar power eliminates the need to have reliable electricity in homes for remote learning. This is why my innovation uses solar power rather than electricity. This chart shows that 2/3 of children between the ages of 3 and 17 around the world don't have access to the internet at home. The majority of this 2/3 are in developing countries. This chart shows that 63% of young people between the ages of 15 and 24 around the world don't have access to the internet at home. The majority of this 63% are in developing countries. This graph shows the population between the ages of 3 to 17 and the percentage of this population that doesn't have internet at home in different parts of the world. Globally, 67% of children between the ages of 3 to 17, which is 1.3 billion, are unconnected at home. If the need for internet access for remote learning is eliminated, many of that percentage would still be able to learn if they couldn't go to school. This graph shows that the number of children that are out of school in Eastern and Southern Africa has almost doubled due to the pandemic, with 37 million out of school before the pandemic, which rose to 69 million in the last couple years. The EduComm device provides an alternative option to the traditional remote learning options, which would help provide easier access to education. These two graphs show that the EduComm device can educate 65% more of the world's population than alternative options such as walkie-talkies to traditional remote learning, just by having a screen. In conclusion, based on my research, I have found that my innovation is a good alternative option for children in developing countries to receive an education, regardless of previous factors that have and are currently preventing children from receiving a stable education. My hypothesis was correct. By changing the platform, internet, cellular data, Wi-Fi, etc., used for remote learning, it eliminates many of the barriers around education that prevent children in low-income countries from receiving one. It also eliminates the need for electricity. Therefore, the EduComm device makes receiving an education almost fully accessible. Thank you for listening. I am very passionate about this, and I think it can make a huge difference to accessibility to education in developing countries.